Hello, Doc Sketchy back with you. Today we're going to lay out a PCB in Excel. This is how I've laid out all my PCBs for all the circuits I've ever built in my whole career as a synthesizer builder. I'm using Excel 2003, which is which runs from Windows XP. People say, Dixon, you're crazy for using such old software, but I think you'll see after today's demonstration that what I do in this version of Excel would be almost impossible to do in later versions. Okay, so the circuit we're going to lay out today is an LFO. It's a morphing LFO. This is the schematic. So basically it generates triangle and pulse, but this potentiometer here is a shape pot which allows you to morph from saw to triangle to ramp. And then the pulse changes its pulse width. This circuit also has a polarity switch. Now this would be a double pull, double throw, on switch. So a 3-position switch. And I'll demonstrate what all this does. It also has a slow switch to go from regular to extra slow. And with the capacitors I've got in here, it'll get 10 times slower when you flip the switch. All right, so let's put an oscilloscope on here and see what this thing looks like. I'll make the triangle red and I'll make the pulse light blue. Okay, now 50%, 50%, and I've got LEDs on here as well. All right, let's play. Takes it a while to start up in the simulation. It doesn't take any time at all to start up when it's in real life. Okay, so there we go. I'm going to make these 2-volt graphicals, so 10 volts peak to peak. The red is the triangle, obviously. Make it a little bit bigger, and the blue is the pulse. Now, if I do the shape, if I turn the shape down, you'll see that the triangle becomes a sawtooth, and the pulse gets very narrow, or basically disappears. And if I go the other direction, the triangle becomes a ramp, and again the pulse gets very narrow in the other direction. And this is my rate, so if I want to turn it up, it goes faster, and if I turn it down, it goes a lot slower. Okay, so I'll leave that at 50%. Now, I'm going to turn off the triangle, and I'll demonstrate the pulse polarity switches. So this is, if I flip it up, I think I get just the upper pulse. And if I flip it down, I get just the lower pulse. And then in the middle, I get the full pulse. This is a very useful feature. And if I flip the rate switch, it goes 10 times slower. 10 times slower, 10 times faster. Okay, so it's a pretty cool LFO. All right, so I'm going to get rid of this. And then I'm going to go back to the spreadsheet. Now here's my blank canvas. The very first thing I need to do, first I'm going to make this a little bigger, so 150%. Then the first thing I'm going to do is get myself a square grid. And I've learned through experience that I need a 16 pixel and 16 pixel. So there's my square grid. Then the next thing I'm going to do is turn the whole thing turquoise. All right, now let's go back here and let's grab the schematic. We'll copy, and we'll come in here. We'll paste it as a bitmap, and I like to make it 60%. It's a nice size. Okay, so then finally we're going to set up our board. So all of my layouts, all of my analog layouts that are just one level are 2.1 inches wide. So I need, since these are 0.1 inch grids, I need 21 rows. And then I just need a random number of, I don't know how many I'll need. I'll just make that many. Turn it tan, put a box around it. So that's my blank canvas, more or less. Now I've actually done this layout. It's over here. So if we just look at, I've got diodes, I've got resistors, I've got jumpers, I've got a chip, I've got power header, I've got electrolytic caps, ceramic caps, film caps, and yeah. So the first thing I'm going to need is this power header. So I'm going to build the power header. Now this is a 0.1 inch grid, but the power header I use has a 0.156 inch spacing, and that's the that's the power header that's used in the so-called MOTM and FRAC synthesizers. So I'm going to build that. I'll show you how I build that. So the first thing I'm going to do is open up a new spreadsheet. Now, since it's 0.156 inches and our original grid is 0.1 inch, I need to create a grid that's 1.56 times bigger than the other one. So 1.56 times 16 pixels is 24.96. That's 25 pixels. So I'm gonna take one row and I'm gonna make it 25 pixels, and then I'm gonna take 4 columns and I'm gonna make those 25 pixels. And then I'm going to highlight the cells of interest in yellow. And then I'm going to make this 400% so it's easier to see. All right, so these are now 0.156 grid. So the first thing I'm going to do is put in a ghost square. Now you'll notice over here this little button. By the way, these buttons on the left and on the bottom are only available in Excel 2003. That's why I use it. It's just so useful. This first button is snap to grid, so I need to snap that. Then I'm going to get my square tool, get my rectangle tool, make my cursor an arrow, and I'm going to make a rectangle. Wait a second. I'm snap to grid. Rectangle. There we go. Now, I don't want this rectangle to have any fill or a line. It's a ghost rectangle. Now I'm going to make a circle. And you'll see the circle just automatically fills the whole square. Now I want to make this 4.5 point circle. And then I want to make it 60% size. So lock aspect ratio, 60%, 60%. There we go. Now I'm going to grab the circle and the square. I'm going to align them using these handy alignment tools, align center and align middle. Then I'm going to group them. So to group, I just Alt R, and then group is G. Now they're grouped. Now black is minus 15 volts. I do a minus 15 plus 15 volt power supply. So I'm going to copy that, make a new one. This one is going to be green. That's for ground. There's 2 grounds. And then the last one for plus 15 volts, I make red. Oops, made a mistake. Just want the circle to be red. Okay, now I'm going to group all those together. Our group, Control copy, bring that to the other sheet, Control V. Now I'm not done. I need to make a ghost rectangle around it. Okay, now that Alt R, R, K, send to back, and then align, Alt R group. Okay, so there's my power, the power header. Does it look right? Yeah. You know what? I'm going to make the rectangle 2 spaces wider. Align. Group. There. Now, Control copy that. Flip it 90 degrees and put it into position. And it should go right in the center. So to check that it's in the center, I'm going to count the squares. I've got 6 squares there. I've got 6 squares there. So it's in the middle. That's what I want. And 15 volts is on top, minus 15 is on the bottom. All of my layouts are just like that. Now the next thing I need is some decoupling capacitors. I'm going to just go grab the capacitors from over here. I'm too lazy to build them as you watch, but they're just built from ovals and circles and what have you. Put them over here, and then so I'm building a bill of materials as I go. So I'm just going to leave those there and copy them and bring them over here. So an electrolytic cap will go there, an electrolytic cap will go there. The ceramic cap will go there, the ceramic cap will go there. So this is 10 micro and 0.1 micro farad, and that's my standard decoupling technique. Now I need a ground trace. So the ground trace goes here. All my traces on this layout are 2 1/4 point, and the ground is going to be bright green. And then I need to connect those to the pins, power pins. So there's that, and that. And then I need to connect up the capacitors. So right click, format auto shape, colors and lines. Give it a ball end. There we go. And put one on the other side as well. And then give this one, make this one twice, and give it 2 ball ends. Put it there, and then put one there. Now I'm going to copy this, make it black, and connect up the negative power pin. And I'm going to copy that, put it up here, flip it upside down, make it red, and that connects up that. So now I'm going to take this, copy it, make it red, take that, copy it, make it black. Finally, I'm going to take this one, move it to the middle here, take this one, move it to the middle, and then take that all the way across the board, make it no balls, no ball ends. Same thing with the black. So now I've got my power rails. So my power is all set up. Oops. Okay, now I'm gonna save that so that I don't lose it. Now I need to make it. Now we need to look at the. Let's look at the schematic, and let's just come up with our scheme here. First thing I need is some op amps. I have 1, 2, 3, 4 op amps. For this, I'm going to use a TLO74, and I'm going to show you how I make a chip. So first, I start with a line, 0.3 inches. There's a 0.3 inch line. Give it ball ends, make it 2 1/4 point, and turn it middle gray. This middle gray. Now I need 7 of them because there's 14 pins. Copy, copy, copy. Control C, Control V, up, Control C, V, up, Control C, V, up. And then this is going to be pin 1 right here in the lower left corner. So I need another one. And I'm going to just put that in the corner, and I'm going to make it black. Now I'm going to group all these. RG. Now I need the body of the. So I need a rectangle. There we go. No, for that I want to use the dark gray. Actually, no, I think I usually use the middle gray for that. And no line. And now I need the scallop to show which end of the pin is which. So I need another square over here, And for that, I'm going to use the no line and the lightest gray. I'm going to group all that together. Group. So now this is a generic 14-pin IC, through-hole IC. And it could be a logic chip, it could be a quad op amp, it could be anything you want. So now I'm going to right-click on the rectangle, add text, type TLO74. Then I'm going to right-click, format auto shape, alignment. I want that in the center, and I want that to be white text. There's an op amp. Copy. Let's go install it. Okay, put it in the back. I always put the parts behind the traces. Now we have a problem. TLO74s, like many quad op amps, or maybe all quad op amps, are oriented upside down relative to other chips. In other words, even though this is the positive rail, this is the negative power pin, and this is the positive power pin. So I need to flip this, I need to turn this chip 180 degrees. So I just go down to my handy dandy turning tool here, rotate right 90 degrees, rotate, rotate, and now pin 1 is in the upper right hand corner, and but the text is still right side up, you see. So that's handy. Now I need to hook it up to power. There's that. And there's that. So now my op amp is hooked up to power and everything's copacetic. And if I want to move it around, I just grab all that and just slide it back and forth with my arrow keys. Okie dokie. Now, I'm going to create a little bit, save that. I'm going to create a little bit of space here. I think 5. Insert 5 rows. Okay. Now, if we look at my finished layout, you'll see I have these indicator flags. So I'm going to make some of those. For that, I go to Auto Shapes, Block Arrows, and it's this pentagon. And it just looks like so. I usually make it light pink, and then I add a ball-end line to it, like so. And that's going to have one ball, and it's going to be, I want it 1 point. Group. Okay. Now, the first thing I'm going to put on the board is this rate pod. So for that, I need to go get another rectangle, and it's going to go up here. I need three grids in there. So that's a 3 grid. Now I usually make these a little bit transparent, so 20% transparent. And yeah. So this op amp is going to be this upper right one, this first op amp. So I need a trace. For general traces that aren't power or ground, I usually use hot pink. So we'll just make that, oops. We'll make that hot pink. And I need to go from the middle of the pot to the plus of the, for now I'm just going to put that straight up on top of that. And then I'll make that a double ball end. Okay, now the other side of the pot is going to hook up to something. I'll just make that hot pink. It's up here. That's a bunch of stuff we're not ready to do yet. The other side of the pot goes through a 3.3K resistor to ground. So my ground, I got to put on some ground traces. So let's go from there to that level. Grab this guy, copy it, flip it, move it up here. Do the same thing on the other side. Yeah. Oh, before I go any further, it should be noted that these electrolytic capacitors, sometimes they have pins that are, or leads that are 0.1 inches apart. Sometimes more often they're 0.2 inches apart. So what I'm going to do is I'm going to actually create a second trace here that's so that I can conveniently have a 0.2 inch space. So this way it's either it could be 0.1 or 0.2. Both will work. All right, save. Now I need to make this resistor. So how do I make a resistor? Well, it's easy. I just need a line. I need a 0.4 inch line, so there it is. I need ball ends. I need to make it 2 points. I need to make it the darker gray. And now I need another rectangle for the resistor body. Looks like that. That's going to have no line. These are going to be 5% resistors in this circuit, so I'm going to make them tan. And then I need to put the values on. So we'll make a 3.3K. So I need a line, and another line, and another line, and another line. I should have done this before. All these lines are going to be 2 1/4 point. I'm going to take off snap to grid. I'm going to put these lines in their proper places. So these are going to be the two mantissa lines. This will be the exponent line, and this will be the tolerance line, which is a little bit further away from the other lines. All right, this one's going to be light orange. Oops. Light orange. This one's also going to be light orange. This one's going to be red. That'll give me 3.3K. And then the tolerance line is brown. Now I'm going to group these together, or group, and I'm going to make it a little bit narrower so that it looks like a resistor. There. Now I'm going to align these two in the center and group them. Group. But I'm not done. I need a ghost. Let's see. Those aren't aligning properly. Okay. I need a ghost rectangle. So I'm going to go here and grab a, oops, but I need to put snap to grid, get my rectangle, make a 2 by 4 rectangle with no line and no fill. And then I'm going to align the wire with it. And then I'm going to align, just going to move this over by eyeball. Now I'm going to group those together. Now I have a resistor that will snap right into the grid. Okay, so I'm going to put that here. And then I'm going to connect that to the one side of the pot, and then the other side is going to be connected to ground. Like so. And I've just connected up this, and then of course the op amp is a follower. So it's minus and out are connected together, like so. All right, so that's that op amp. Now this op amp here is going to be this one, the bottom right. So first I need to make a 1K resistor. How do I do that? I'm going to put this down here on my BOM. I'm just going to copy it, and then I can just change these lines. So for 1K I need brown and black and red. So there's a 1K, and I need 1, 2, 3 of those. All right, so let's take one up here. Okay, put it behind the traces. Copy V, and let's connect it to the output of that op amp. And now I need diodes. Diodes are made in exactly the same way. I'm lazy, so I'm just going to go grab a couple of diodes, or grab one diode. You'll see that for diodes, I tend to make the rectangles a little smaller. Oops. And I need 4 diodes altogether. So let's bring one over here. One of them needs to be upside down compared to the other one. And let's hook those up. Those hook up to the 1K. And then like so. And now I need another pin header for the shape pot here, B. And so, oops, those connect to the 2 diodes. Alrighty. Now the middle of the shape pot goes to the negative, which is here, of this op amp. So I'll just put that like so. Connect that up to there and make it okay. The plus is grounded. Sorry, that goes like that. That's the negative. Plus is grounded, so I'll just bring a ground trace over here. And yeah. Now I need a 100 nano and a 1 microfarad film capacitor. So how do I make a film capacitor? That's easy. I just take a line. This time it's 0.2 inches. 0.2 inches. Again, ball end, 2 1/4 point, and dark gray. And then I just make a simple rectangle. This is going to be no line. It can be any color you want, but I tend to make my capacitors light yellow. And then I make it a little bit transparent, 20% transparent. Okay, and then group those together, or align them, group them, and then again I need a ghost rectangle. And let's align those, group them. Now, oops, let's add some text. It's going to be a 104. Let's make it 8 point. And let's, for alignment, let's do it this way and put it in the center. Center, center. Okie day. There's my film cap. So it's going to connect between negative and out. So these 2 pins. So let's put it somewhere. Actually, let's turn it and realign the text that way. Okay. There. And then I've got an out trace here that goes to the next op amp. And for that I'm going to need a jumper. The jumper is just a ball end line that is 3 point and that is dark blue. Okay, now I'm ready to do all this garbage. And this is where I'm going to stop with the demo. But I did want to add some text here. This is going to be the rate pot. Make this 8-point. And we're going to align it center, center, like so. And we're going to flip this that way. Going to ungroup, going to copy this. So that is going to be my rate pot indicator. We can leave it in front. Okay, so that's basically how the layout goes, and you just keep going until it's all done. All right, now I'm going to go over here and show you the final layout. Now you'll notice that the final layout is very compact. So let's just check it. So starting where we started, the rate pot, the middle goes to plus, minus and out are connected together in follower fashion. 1K down to the bottom level, to the two diodes to the shape pot. The middle of the shape pot goes to the minus of this op amp. The plus is grounded. And the minus also connects through the 104 or the 100 nanofarad film capacitor to the output. The output goes to the cap switch. The other side of the cap switch goes to a 105 or 1 microfarad film cap, which is also connected to the minus of the op amp. And the output of the op amp then also goes to 82K into the plus of this op amp. The minus of this op amp is grounded. This op amp is a comparator. And then the plus connects to a 10K to ground, 10K to ground, and 220K to out, 220K to out. And between plus and out, there's a 10 picofarad ceramic cap, stability cap. All right, and the output of that goes back to the top of the board. It goes to the other side of the rate pot. Okay. And then it goes forward. It goes 10K to the LEDs. The LEDs are on the panel, but so we just need to have connectors here. So these are going to be the LEDs. This one is the 10K, and then the ground connection. And then this also goes to 220K, this sideways resistor, to the negative of this op amp. The positive of this op amp is grounded. And because things are so crowded here, I put the ground underneath the chip to the other side where it's less crowded. And so I put jumpers across to connect the two power pins to the power rail. This minus also goes to the polarity switches. So this minus connects to one pin of the polarity switch here. The polarity switch connects in 4 places to the circuit. So there's 4 connections. Then that goes through an 82K to the other side of the polarity switch here. And then that goes 1K to the pulse out here. And then the output of the op amp, this one, connects to 2 diodes in opposite directions, which go to 2 other connections of the polarity switch. And that's the whole circuit. So we've checked it, it all looks correct, and now we're ready to make our layout, make our transfer for building the PCB. Okay, So we've got our complete layout. And now we need to make the transfer for the for making the PCB. So what I've done is I've reproduced the size of the whole board here, first in a tan and then in some whites. So the first thing I'm going to do is I'm just going to grab everything except the flags, and I'm going to move it down here to this next tan box, and then I'm going to do it again and move it down here to this white box. Now the first thing I'm going to do on this box is I'm going to get rid of all the traces. So I'm just going to delete all the traces. Oops. Try not to delete the parts. This usually goes pretty quick. I have a lot of practice doing it, so I'm going to just show you the whole process here. It's a little bit tedious, but what else do you have to do, huh? All right, just and since all these parts have invisible boxes around them, even if I grab the area around most of the part, I can still erase just the traces and the parts won't disappear. So that's kind of handy. Now I'm going to gather up all the parts, group them together. Now on this one, I'm going to get rid of all the parts. Now I'm going to gather all the traces together and group them. Now the first thing is all these traces are going to be converted to 3-point, and the balls on these traces will actually be the pads. Now I'm going to copy all that, and I'm going to set one copy aside. Then I'm going to go back here, copy it, paste it, superimpose it, convert them all to ball ends, convert them all to 2 1/4 point, and then right click, format object, and make all the balls small. And then I'm going to copy it again, superimpose it, make them all non-ball lines and make them 4 1/2 point. So you'll notice that now the corners of the traces are rounded, and that's what the 2-point balls did. Now I'm going to group all that together. Now over here, I'm going to ungroup those, and then I'm going to get rid of all the pink traces, just leaving behind the power and ground traces. Okay. Now I'm going to group all those. I'm going to make those are already 3-point, you see. I'm going to make them all ball ends. I'm going to make all the balls small. Then I'm going to copy and superimpose those, make them all no ball, 6-point. And so the 3-point balls make nice corners on the 6-point corners. Then I'm going to group those, and I'm going to superimpose those on top of these, and those are my traces. And I'll group all that. Now, the next thing is to make the pads. Now, I just copied these pads over. These are the pads for the power header. These are corner mounting holes, so drill holes for the corner mounting holes. And then these are pads for the off-board connectors, and these are drill holes for everything else. So first thing, I'm going to take all these up to the bring them to the front, bring them up here, superimpose this one on top of the power header. Make this, put these in the corners for mounting holes. Put these on the pin headers. Grab all 6 of those, copy, paste, move those down here. And then these drill holes are going to go everywhere else. Remember this one here, I have an extra hole for the 0.2 inch ceramic cap. Now then you just put in Control V, Control C, V, up, down, Control C, V, up, down, up, 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 Control C, V, and then just do it again. Okay, so I've got all the pads. I think I do anyway. So grab all that and then click somewhere on the part that doesn't involve a pad to deselect it. Group all that. Yeah, and then move it down to this block. So I've got my traces and my pads. Now I'm going to copy that down here. Go up here, grab the traces, copy those, put those here, turn them black, put them in the back, and group that together. Now that's pretty much my transfer, except there's one other thing I'm going to do. I'm going to go put in make a line here. I'm going to turn it bright blue and make it 3-point. Make 5 of those. Grab those, Control copy, put them up here. Grab 3 of them, Control copy, put them here. Then I'm gonna group all those together. Group, turn off snap to grid, and then go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And those fit nicely in between those big pads to make a little bit of space so I don't get solder bridges when I solder. Then I'm going to turn those white, and then I'm going to group that with everything else. And that is my transfer. Now I'm going to copy it one more, copy the whole thing, snap to grid, put it down here, cover it up with a white square, turn off the line, make it 20% transparent so we can see the stuff through it. And then I'm going to go grab the parts and put the parts on it. Group that all together. And that is what my board's going to actually look like when I build it. And this is what I look at when I build the board. Now, final thing is I need to open up PowerPoint, get rid of this trash, go back here, grab the transfer, Control copy, move it into PowerPoint, Alt paste special, picture enhanced meta file, and then right click it, format picture, and make it 60%. That's the magic number. And then I put it in the middle of the page. Now, if I right click on this and find the size is 2.1 inches by 1.9 inches, exactly what I want. So this I can print from PowerPoint to my LaserJet printer, and it makes exactly the thing I need to transfer, and it's the right orientation. You don't have to flip it. Alrighty. Now, before I end this video, I just wanted to point out, if we look at my layout style, 2.1 inches, 21 grids, power rails and ICs go in the middle. There's one row for random stuff like this sideways resistor or these stability caps or other caps. And then all the resistors and diodes are 0.4 inches, 0.4 inches long, and they all go here. And then off-board connectors are the next row, and then the ground trace is the next row. And the 3 spaces underneath the resistors and diodes and whatnot, I call the boulevard, and that's where all the signals go from left to right. They go underneath. So some of my boards are very, very big and the boulevards can be very long. But all of my analog layouts follow this exact same pattern, and that's why it's very quick for me to do these layouts. This layout I actually did in about half an hour off camera. Okay, so that's the video. This is part 1 of the video. The next video, part 2, is going to be me actually making this board from scratch, showing you the transfer, the etching, the drilling, the stuffing, and then I'm actually even going to test it and make sure it works. All on the video. And I hope to get that video up in the next couple of days. Okay, so thanks for your attention. See you then.